Okay guys, so the project this week was Plotbot. We built a robot, or assembled a robot, that was to somehow have a marker mounted on it and was to draw a square on a piece of giant graph paper autonomously. So when you think of robots, you normally think of autonomous movement, like the robot's doing something all by itself. So we're not pressing a switch and it goes forward. It knows when to go forward and when to turn. So how would you do that without using a switch? Well, for the first time this year, we're using the Arduino. So we put the Arduino back into our projects, and just like the DP-DT switches last week, we now have 5-volt DP-DT relays, which the Arduino will manipulate to move the robot forward and backwards. So the goal was to use the 5-volt relays, and also this was the first group project of the year, which it went pretty well for being the first one, so that was good. How we started out in this project was we were given the robot kit and told that we had to write some code for the Arduino so that the robot could draw a square by itself on the pre-drawn lines of the graph paper. It didn't have to follow the lines, it just had to sort of match where they were going. So since this was a group project, we all had roles that we had to fill. We had the sort of assembler who assembled the robot and mounted the pen to it. We had the coder who wrote the Arduino code, the circuit designer who made the circuit, and the power technician who figured out how much power we needed to use the robot and what the ideal power was to drive it at. The power designer also had to think of things like how would the robot drive on the paper versus the ground and stuff like that. So we got to choose our roles if you knew what you wanted to be and you set it fast enough. So I wanted to be the circuit designer because I felt that it gave me the most weight in the project. Like, this is how we're going to do stuff, so that's what I chose. And the circuit design I thought of was based off of a great tutorial that we found for 5-volt relay motor control. There's a link to the tutorial on my blog, and the circuit is exactly the same. What we did was you had the 5-volt relay, a tip 120, and a NPN switch, so the 2N3904. How it worked was the 5-volt relay worked just like the DP-DT switch from last week, except that it has 8 pins now instead of 6. So the pins that it had was the bottom 2 pins were power and ground. The top 2 sets of pins were the normally open pins. The middle set was the collector, and the bottom set was the normally closed. How it worked was it was sort of, the relay was sort of made so that as soon as it got power, the collector would connect the normally open pins. So in this case, if the tip 120 had power on it, the whole circuit would have power and the robot would drive forward because the normally open pins were connected. However, if the tip 120 was on and the 2N3904 was on, the collector would be given power and it would change to switch to the normally closed pin, and then this would change the direction of current in the gear motors and they would drive backwards. So that's how we moved the gear motors forwards and backwards. So once I got one circuit figured out, I decided that it would be the easiest and most time efficient if I just made a second circuit and wired them in parallel to the same power and ground. That's what I did. It worked great, and so the circuit was done. Now, because this was a group project, you had to rely on the people for the code and the robot and the power and stuff like that. And also because it was in a short time period, we didn't have a lot of time to test. So once we put the code on it and ran it a few times, the angles that the robot would turn at were a bit off, so it ended up just drawing a bunch of squares, sort of each getting more diagonal, which it did draw a square. At least it connected the 4 the four sides, but it didn't draw the same square over and over again, which would have been the ideal result. So I think overall the project went really well. The code for the project is on my website, but I will take a minute right now just to quickly go over. Okay, so here is the code we used for powering our robot. So we define our pins up at the top. Our motor pin is pin 4, which is the tip 120. Our direction pin is 5, which is the NPN switch. We have another set of motor and direction pins because we're using 2 circuits, one for each wheel. Our delay time is 326, which was calculated by measuring the wheels, radius, and how many squares it would drive in one rotation. I'm pretty sure this isn't my code, so that's what I'm getting from this. And turning is, it's on for 1.25, found from a base number, then trial and error. So it kind of worked. So this void setup sets all the pins to output because we're not reading anything. And the void loop moves forward and right. So because we're driving in a square, we all need to move forward and right every time. The move forward, so it gives power to both tip 120s. So one tip 120 in each circuit. Both are high, so both gear motors move forward. And then it stops at the end. So move backward, both tip 120s, one in each circuit, are high, and also both NPN switches in each circuit are high. So when I said before that when you power the NPN switch, the collector changes to normally closed, that's what's happening, so it changes the direction of current and the motors move backwards. And then it turns off at the bottom. Move left, so we would take the left motor and turn both the tip 120 on and the NPN switch, and on the right motor we would just turn the tip 120 on. Therefore the left motor would move backwards, the right motor would move forwards, and it would turn very quickly to the left. Move right, it is the same thing, just the opposite of left. So this is the code we used. Obviously, if we had a little more time, we could find the turning number a little more precise than trial and error, but it seemed to work pretty well, and all in all, it was a pretty good first group project. Lastly, this is the motor control schematic I based my circuit off of. It's really great. There's a link to this on my blog. It's right here. I say great tutorial for 5-volt relay motor control. That's it right there. We have my parts list, and I have a sort of typed up circuit description in case you couldn't quite follow what I was saying. So there's also a Fritzing diagram of my circuit, and yeah, I hope you like it, and talk to you guys next week.